And welcome to our speaker today, Su-Min Chun from FriendliAI. And so Su-Min Chun is a software engineer at FriendliAI, which is an inference platform company. And according to her description, so she's dedicated to making AI more accessible by lowering both technical and financial barriers. During her time studying computer science at MIT, she discovered a love for building great ML software and enjoys optimizing code from the algorithmic level down to hardware. Her diverse experience includes working as a founding engineer at an edtech startup, working on ML ads team at Meta, and dabbling in quantitative finance and conducting data visualization work at MIT CSAIL. So that's really interesting. Definitely want to chat to you more about the edtech startup. I found interested in that myself. I was also at Meta too, so
Nice.
lots in common. But I want to hand the floor over to you now. So take it away, Sumin.
Thank you so much for the introduction. Hi, everyone. I'm Sumin, and today I'm going to be talking about accelerating AI agents with multimodal RAG using Friendli Endpoints and Milvus. So by the end of this talk, you'll know about large language models, large language model inference serving, AI agents, and how to build a simple working version of an AI agent for yourself. So you already heard a bit about me, but yes, I'm a software engineer at FriendliAI. I studied computer science at MIT, and the summary is that I'm interested in making things run faster. To explain a little bit more about FriendliAI, we are a leading provider of generative AI infrastructure, and so we want to make generative AI accessible so that anyone can build and host generative AI services without being hindered by latency, cost, or technical barriers. We're very good specifically at generative AI inference serving, and if you don't know what that means, I'll start by explaining it. So to go over the agenda for today, I'm going to start off with some background. AI agents are all the rage. You've definitely heard of it already, and some of you might be quite familiar with it already, but I want to paint the scene of the current generative AI landscape, um, as well as inference serving and AI agents. Then I'll explain the problem, the challenges in building AI agents, and the solution by using FriendliAI and Milvus to address some of those challenges. Finally, we'll go through a live demo on a Colab notebook. So to start, there is an increasing use of open source generative AI models. Models like Llama, Cohere, DeepSeek listed down there below, and many companies are embracing these open source generative AI models. Why is this important to us? So I want to make the distinction between open source and closed source models. And these companies spend lots of money to train really good models and make them open source. And we can do something called fine tuning to create models for our own purposes very easily. So to give an example, if I'm like a medical startup and I have a medical data set, I can fine tune an existing model like Llama on that data set and make it really good at that specific use case of diagnosing patients, for example. And so you can also use them without fine tuning since these models are publicly available. But just because they're publicly available, how do we actually use them? And that process is called running inference, which is what FriendliAI does. Just how good are these open source models? You've probably heard of DeepSeek, which made waves last week or the previous week when it came out, DeepSeek R1, for being just as good as OpenAI's closed source models, and at the same time being a lot cheaper to train and run. And this is, I think, partially because the training data in the world is limited, and these models have already been trained on all the data that there is out in the world. So that's great news to us for building AI agents and using open source models to do so. That means we can get really high quality responses. What does it mean, though, to be cheaper to run? And what does it actually mean to run a model? To help build some background into the inference serving problem, I want to start by explaining the fundamental of what a large language model is. I assume some of you are already familiar, but for those that are not, this is a screenshot of the Llama 3.1 70 billion instruct model on Hugging Face. And what you see here on the side are all its parameters. So the 70B here means it has 70 billion parameters. And these large language models are trained on vast amounts of text to understand and generate human language. So they have all these parameters, billions of parameters, and they have architecture, which you can think of as just like the operations to get from the input to the output. So these models are open source. We have the parameters and architecture. And there are also other models, in addition to large language models, which are trained on text to understand and output text. We have vision language models like Meta's Llama 3.2 Vision, which can describe images, as well as image generation models, which can generate images given a prompt. And this multimodality is going to be a big reason why databases like Milvus are very useful and will become even more useful for generative AI applications. Finally, what is generative AI inference serving? So it's how you can actually start using the model. It's the process of deploying a generative AI model where it can receive input prompts and generate text responses in real time, serving up the results through an API or similar interface. You have the weights in the architecture, so this is actually getting the results from it. This diagram that you see here is an example of large language model inference. You get the prompt, is apple a fruit? And there's a lot that goes into it, but to simplify it, it'll tokenize the prompt into separate words, is apple a fruit? It'll run those tokens through that entire architecture, the operations, which primarily consists of like matrix multiplications and activations. And then it'll do this many, many times. So for each new token that it generates, it has to run through the entire architecture with all those billions of parameters. So you can see how for a long input and a long output, this is going to be extremely computationally intensive. You can't just run this on your computer CPU because, like we said, the models are massive and the computations are also going to be massive. So with the exception of some tiny models, most will require GPUs, hardware specialized for AI applications. And these GPUs are very expensive and they're also kind of in a shortage, so they're hard to find. It can cost you hundreds of thousands a year. And so efficient inference serving is going to be very important in AI applications. Next, I want to briefly go over what an AI agent is. It's a software system that autonomously interacts with its environment to achieve goals. And as you can see in this diagram here, it's going to use multiple large language models at once usually. It's going to be a step up from the normal AI chatbots. The difference is that the agent can do things like analyze data in real time and make decisions with minimal human input. It's powered by large language models, and like we said, they're going to be large with very many weights. If you use multiple of them together at once, it can be very expensive to run. An AI agent can also do things like retrieval augmented generation, or RAG, to be able to use a database of up-to-date information. And they can also do things like tool calling. So tools are specialized functions, APIs, or external resources that the agent can access. So they might be able to do things like search the web, check your calendar, run a calculator, write code, and you can always also add custom tools. So we could theoretically add a tool to buy a ticket given the right endpoints. And I see an AI agent as two important things. When you give it a prompt, it should be able to reason on its own and figure out exactly what step to take. And number two, actually be able to take the step. So for the first step, for the reasoning, The AI agent will use these large language models or large multimodal models, and for the actual actions, it will use tool calling. So what are the challenges in building or running an AI agent? A good AI agent should give responses that are high quality, fast, and affordable. High quality is obvious. You want the responses to be helpful. And this can become harder when we include multimodal inputs or outputs. You want the AI agent to be able to process its environment well, whether that be text or images. And so these multimodal inputs will become increasingly important, and Milvus is able to handle those well. Next, the goals of being fast and affordable come from the fact that the AI agent is powered by large language models, which can be expensive and computationally intensive. So lowering latency and cost is going to be extremely critical. For the hurdles of building and running AI agents, the two main components are the actual building of getting a working AI agent. There are many parts to it. You have to figure out the database, the infrastructure, the different functions. And the second part is the running, because you can have an AI agent that works, but you don't want running it to be super expensive and slow, especially at a production level scale. So that's where FriendliAI comes in. We're an infrastructure company in the stack, and compared to existing software, our inference is up to 10 times faster and 90% cheaper. And we do the entire process from fine-tuning to serving. It's extremely simple. You have a model you want to use, and we'll serve it for you. You'll receive back an endpoint, and you can use that simple API interface to interact with the model. So this video shows just how easy it is to deploy models using FriendliAI. We have a partnership with Hugging Face, so I'll just play this video right here. And you can see that directly from any model page, you can deploy using Friendli Endpoints. And it's loading, it's deploying. And yeah, you can see the playground here where you can chat with it and see the health of the endpoint. Extremely easy. You can see us as an inference provider on any model page. And so not only is it easy, but we do it very well. This is from a third-party benchmark provider, Artificial Analysis, and it shows that for a single request, FriendliAI's inference has the highest output speed while maintaining high quality. Not only that, we have high throughput, which means you can reduce the number of GPUs required and save really big on GPU costs. So this is an experiment where there were a lot of concurrent requests happening at one time. Hard to show with third-party benchmarks because you have to be sending so many requests at the same time, but it's very easy to see how a 4 times reduction in GPUs is going to be really useful. And you might be wondering how. How is all of this possible? It's powered by our Friendli engine, which is a specialized GPU optimized engine for generative AI with a lot of optimizations in it, like batching, caching, and GPU level optimized kernels. So that's on the inference side. On the database side, why should you use Milvus? So Milvus is a multimodal database, and it's really good for unstructured data, such as text, images, and audio that might vary in format. And this is because it will embed these various formats into vectors that capture its semantic meaning. So for example, with the query, what is the capital of France? Traditional SQL databases might look for the exact matches of capital and France in a structured table, whereas Milvus will transform that query into a vector of its own and then search that vector against the other vectors in its database with a similarity search. And Milvus is thus going to be really good for retrieval augmented generation. To give a quick recap of it, these vector representations can capture semantic similarity. And RAG is a technique that improves AI responses by retrieving relevant information from an external knowledge source before generating the answer. So you can imagine for when you're interacting with an AI agent, you ask it a question, it'll look at its database for relevant context, and then it'll add that context to its query before asking the large language model the question. So RAG is going to be really good because before RAG, a trained model only has the knowledge it's trained on, and it can easily become outdated. You could fine-tune it to add new information, but say you're working with a system where information changes every day. Fine-tuning every day is going to be expensive and time-consuming. With RAG, you can just connect an external database. So with that, I think we're ready to jump into our demo. I'll take a look at the questions if there are any. When a user poses a prompt, does the question itself and any information contained become part of the database? Oh, I think that has to do with something called memory, which is another thing that AI agents will have. They'll have like an external like memory source where that can keep track of the history of what the user has asked previously. RAG systems on their own like don't necessarily have to do that. You can just have a RAG of only the documents you want to give it, and you don't have to like save any question data if you don't want to. So that's really up to whoever is building the AI agent. But yeah, we'll jump into the demo. So we'll be using Milvus for our database and friendly serverless endpoints. Friendly serverless endpoints are some models that we have deployments of above already. So these are going to be some popular trending models, and you can simply just call our API. There's no need for you to deploy the model on your own. And you get $5 free trial credit for friendly serverless endpoints, so it should be very easy to follow along with the demo. We'll be using tool calling with a predefined search tool and a custom tool, and we'll be using retrieval augmented generation. So yeah, just hop onto that QR code Colab notebook. And let me switch my screen share to the Colab notebook now. Okay, so I'm in the notebook now. In this notebook, we'll be using Milvus and friendly serverless endpoints. Here's the QR code again, in case you missed it. Yes, some of these cells might take a little bit longer to run, but yeah, let me know if you have any questions at any point. The notebook is split up into two parts. So in part one, we'll be learning how to use Milvus to perform retrieval augmented generation. And then in part two, we're going to use that RAG in an actual AI agent. So in part two, we'll be building the actual AI agent. So let's start with part one. I went ahead and installed these prerequisites already. What we're going to be using in our RAG database are the Milvus docs. So we're just going to be using Milvus documentation. These lines right here are downloading the Milvus docs, and these are just all the dependencies needed. And the AI agent, we're going to be interacting with it in a chat format, and so we'll just be using Gradio for that chat format. So once we've done that, we will read the Milvus documentation files and process them as text lines. So I just opened the file that we downloaded, and if I see what text lines looks like, it looks like this. So for every line it read in the file, it just saved that as a string. Okay. Next, we'll be preparing the embeddings, and we're going to use this embedding model called sentence transformers. It's this one right here. It's just a popular embedding model. And what an embedding model is it takes a sentence, it takes a piece of text, and then it gives you a vector embedding. So like we talked about before, Milvus is a vector database. So what we need to input into Milvus is going to be vectors, and this embedding model will be the one that takes the sentences and turns them into vectors for us. So there are many other embedding models out there. You don't have to use this one, but for this Colab notebook, we'll be using this embedding model, and we have it saved in this variable right here called embedding. So when we call the function embed query on this test sentence, so this is a test, we'll be able to see the embedding. And yeah, it might take a while when you first run it because it'll be downloading the model and all the parameters. But once you have it downloaded, we can see that the embedding dimension is 384, which means the vector that it outputs is going to be that long. And yeah, this is just some values of the embedding itself. So next, we're going to set up the Milvus client for our RAG implementation. That's super simple. I'm just going to call it my RAG collection. And then if it has the collection, we'll create the collection. This is just the collection name, the embedding dimension, which is 384 from above. The metric type, which we'll use as inner product distance. There are other metric types here, like cosine, L2 similarity. These are just all going to be measures of how to compare two vectors. For this notebook, we'll be doing inner product distance, and consistency level doesn't really matter too much for what we're doing here. So next, we have our text lines from above. That's the thing I printed where each line in the file was in our list. And for each line in the text, we're going to be doing the same function call here, embedding.embed query. That's what we did right here for our this is a test. And that's going to give us the vector. We're also going to save the raw text, like the human readable text as well, because that's going to be the information we'll want to retrieve to give to the large language model. So these are going to be the fields that we're storing. So let me run this real quick. It's creating the embeddings, and then we have 72 inserted into our Milvus client. So next, we can perform the RAG query. For an example, let's use this question: how is data stored in Milvus? How you search your database for that is going to be to turn that into an embedding on its own, to turn that into a vector, and then, like we talked about before, compare two vectors with similarity. So like where in the presentation there was like king and queen and how their vectors are off by the gender. Yeah, so we're turning the question into an embedding, and then we'll be searching our vector database for that. We'll ask for 3 results. We're still using the inner product distance, and what we actually want is the text for the output. So let's run that. That's going to be saved in this variable right here, search res. And for each search result, I want to print out the retrieved lines, and it'll show me this. So these are the 3 lines that it thought were most similar to the semantic meaning of how is data stored in Milvus. So this is the output of RAG, and I'll just do some processing in Python to combine all these lines together into one string. And this is because the next step, creating the prompt, I want to put all that context into the user prompt. So you might have heard of prompt engineering. Whenever you're working with large language models, it's really important how you ask the prompt. And one way to do it is to give a lot of context and use these tags. So in this case, we're going to be using these context tags to show the large language model that this is the context you should be referring to, and this is the question you should be answering. So we have our question from before, how is data stored in Milvus, and our context now. So we can create this system prompt and user prompt. I've already entered my Friendli token, but you can do that really easily in the Friendli suite by going to settings. And once I have that done, this is the large language model we'll be using, the Meta Llama 3.1 70B instruct. So we have our system message, our human message, which are these two things, and we'll just join them together and invoke the LLM, ask the large language model to create a response based on those messages. And once we do that, we'll receive this response. So this large language model received these prompts together and then was able to come up with this. So on its own, this Meta Llama 3.1 70B instruct probably had no knowledge of the Milvus docs, but with RAG, it was able to give an accurate response. Let me just check. Yeah, that's good. And then we can execute the RAG query now, which is the complete query. We have a prompt, we pass it into the large language model, and then we just parse the output. This is using LangChain, which is something that you can use to build AI agents super easily. And it'll also be at the bottom of this notebook, how to build an AI agent using LangChain. But yeah, that's basically all that's going on. We already have our large language model, and now we can simply invoke this chain with our input question, and it'll give us the response. It's very similar to what was going on above. For multimodal queries, we can use a vision instruct model. So this is the model that we'll be using. And then we can ask it to analyze this image. So these vision language models are going to be really good at describing what's going on in an image. And yeah, if you run that cell, it'll be able to depict the flowchart of what's going on in that image. One thing I want to note though is that we're using serverless endpoints right now, and for serverless endpoints, the models that we have up on there change whenever like the trending models change. So I believe currently this model is not up, so this cell might not work, but it'll be up tomorrow for sure. And um that's also the deployments that we have. So if you also want to deploy it on your own using Friendli container, then you can definitely get this to work immediately as well. But if you're using serverless endpoints, then these cells might not work right now. And again, with RAG and multimodal capabilities, you combine the context, the question, as well as asking the large language model to answer in respect to this picture, and then it'll be able to give you a response that has all of that information in it. So to go on to the next part of actually building the AI agent, again, we can use LangChain to build an AI agent with less code, but I really wanted for us to get into like the gritty details of what goes into an AI agent and reasoning. So we'll be writing a little bit more code, but hopefully understanding it better. Step one is to define the assistant's desired behavior. So like we said, agents should be able to act autonomously. And this means that for every prompt that the user gives, the agent should be able to determine what action should be required. So whether that's plain text generation, RAG, or web search in our case, and then it should be able to execute the proper action to generate the response. So step two would be preparing our RAG collection, but we'll just be using the same RAG, our same Milvus database as above. So we don't have to do anything else for that. And next is actually building the assistant. So we're gonna have two Friendli clients here. This is where Friendli serverless endpoints again comes into play. We have our Friendli client, which we'll use for plain text generation, and then we'll have our search client, which uses tools. So this will be able to search the web, and based on those web search results, give you a better answer. I separated each option into a helper function. So for plain text, all that's going to do is do a chat completion with this model. So it's going to receive the messages that the user has given. It's going to have all the chat history. And based on that, it's just going to ask it to complete the chat. So that's just going to work very similar to how any OpenAI API works when you just give it a prompt. And then option 2 here is RAG. So this is a helper function, very similar to what we did in part 1, where we have the search results, we get the retrieve lines, we join them, and then we put them into the context tags here. And this is also very similar to what we did above, where we just search the Milvus client for a collection and we embed the user question to get a vector out of it. So this is all basically the same. The only thing different we're doing here is messages is going to contain all of the chat history, and we're going to basically update the last chat, which previously only had the user question, to also have the augmented results. And then once we have that augmented query, we can just perform the plain chat. So that's just this one, just asking it to complete it with the updated query. And the third option is web search. So for here, we're using the Friendli search client, and inside tools, we're giving it web search. So this is a predefined tool. You don't have to do anything else here. It's a tool that we already support. And one other thing that you might be wondering is this parameter here, stream. So streaming is just a method of completion where you receive like every word at a time. Remember in the beginning when I said that every time you get a new token, you have to like go through the whole process again. So for this one, you'll receive every token at a time. And the alternative is to wait for the entire response to finish generating and then receive it all at once. But since we're trying to build a chat interface, we'll just be using the stream method. So if we go into our main chat function here, we have the message, which is going to be the latest message that the user has inputted, as well as the history, which is the history of all the previous messages. This right here is going to be our custom tool. And this is the reasoning that I talked about, where for a user's message, we want to pick which action to take. And the action is going to be one of these three, RAG, web search, or plain. And the description is just the action to take for this question. And so similar to this, you can very easily create custom tools and create chains of reasoning. And so based on this tool response, we can pick the tool choice, the action that the LLM chose that is appropriate for the user's prompt. We'll print the action chosen, and then based on the action, we call one of the helper functions here. So perform RAG, web search, or plain chat. And then finally, this is just code to actually show the outputs from the stream. Let me look at the chat right here. So when it is comparing vectors, the input vector would be fixed, but are the comparisons being made to newly constructed vectors that did not previously exist within the database? The comparisons when you're doing RAG in our Colab notebook is going to be made to, so the vectors we already created right here. So for, no. Oh, here. So for each line, we already created an embedding and we put that into our Milvus collection. So that part is going to stay the same. The vectors inside the database are going to stay the same. And then when we have a question, we make the question into an embedding vector of its own, and then we compare it to the vectors in the database. So the vectors in the database are just staying the same. So you can think of them as fixed as well in our case. Okay. So let's finally try running the chat interface, and we're using Gradio for the chat interface here. So very cool. We'll be able to also get like a link right here that also opens up this chatbot. And if I say hello, it was able to accurately choose the action chosen as plain. it didn't need to search the web or search our RAG database for this. So it chose plain. For this question, it was able to accurately choose RAG and give me a response from those documentation files that we put into our Milvus database. And finally, let me try asking a question that hopefully will prompt it to search the web. Okay, so waiting for tool response looks good. It means it's currently searching the web right now. And yes, so action chosen web search, and the founder of Zillis is Charles Shi. So in just these few helper functions and just this Colab notebook, we were already able to build an AI agent that can take multiple actions, use RAG, and give us a pretty good, be a pretty good personal assistant to us. And here is how to build an AI agent with LangChain as well. If you're curious and not doing all that extra coding, it makes it even less code. Let me check the chat again. Do you also offer fine-tuning services with agent support for that? We offer fine-tuning, and so like agent, if I'm understanding your question correctly, to build AI agents, you need these like endpoints, and it's really good to have structured output generation for AI agents because, for example, for things like tools, you can define custom tools, but you need the AI agents to respond in the same like format each time. For example, like JSON format, like give me the action in this specific format. And that's called structured output. So we support that. We support fine tuning. And based on that, you can use our endpoints to create AI agents. And for the question, how does tool calling differ in a multimodal system compared to traditional text-based RAG pipelines? Specifically, how do we handle modality specific tool invocation? So for multimodal inputs, like this example with the image URL, I would imagine that for tool calling, like you could have additional tools for image processing, but like the actual you would only the endpoint would change. Instead of using like a large language model, you could use a vision language model instead and put those inputs and the RAG retrieved outputs, as well as like if you have for example, multimodal inputs in Milvus, for example, you have like the embeddings of the images, you can also store like captions of those images. And if you are, for example, retrieving with like a specific query and there's like an image match, like if you also support that in your AI agent where you can show images, you can also do that. You can output the captions as well as additional context. So there are many ways to do it. Essentially, Milvus is just going to help you store whatever data you want to store, unstructured data in an vector embedding format, and friendly serverless endpoints is just going to help you use whatever model you want to use. So in between, like how you want to use the combination of the two is, yeah, there are many different ways you can use it. But yeah, let me switch back to my PowerPoint. And so we were able to build a simple example of an AI agent, but if we were to think of it at a production level scale, like what else might we want? And we would want it to scale, and we might want to use custom models, like someone asked about fine tuning. For that, we use serverless endpoints, for example, but friendly dedicated endpoints is going to be what you'll want to use. So friendly dedicated endpoints has everything from fine tuning to model serving. And so it's a convenient cloud-based solution to use your custom models on the GPUs of your choice without the operational hassle of managing your own infrastructure. So you can either choose your own custom models or open source models, and it has auto-scaling, failure management as well. Fine-tuning is going to be extremely easy, like in this screenshot here. You just choose a model, you choose a data set, and then you'll be able to fine-tune it. And once you do that, you'll have an endpoint from it. Deploying it is super easy as well. All you do is select what type of GPU you want to use, and that's pretty much it. So to summarize, you can build AI agents efficiently with FriendliAI and Milvus. RAG is one of the most powerful tools out there, and with Milvus, as the evolution of generative AI continues, the vector representations will be able to support it. And both FriendliAI and Milvus support generative AI applications at scale, so you can enjoy low latency, low cost inference serving on a production level. So thank you so much. And yeah, we have a partnership with Hugging Face. So on any Hugging Face model page, you should be able to see us immediately as an inference provider. Here are some links to our website and a link to the Google Colab again. Yeah, thank you so much. Let's start building together.
Thanks so much, Simon. Really interesting stuff. So I think we've got a bit of time. I wanted to hand it over to the audience. We could have like a Q&A session. So please write your questions in the webinar chat and make sure you select to everyone, not just to hosts and panelists. But while we're waiting for that, I got a few questions myself, so I'll kick us off. So what you want to ask about is what's sort of like underlying this faster inference? I mean, do you have sort of like non sort of standard hardware? I don't know whether that's from companies like Nova or etc. So how exactly are you providing faster inference?
Yeah, that's a great question. We are a GPU-based API provider or GPU-based inference provider, so we don't use specialized hardware. Um, so compared to all the GPU based providers, we can say that we're the fastest. And it's going to, like, people ask if the specialized hardware is worth it. And I will say it is definitely fast, but it's going to be a lot more expensive and it's going to be a lot less flexible. So if you're trying to work with custom models, it's going to be a lot less flexible for that. Um, yeah, and how we make it so fast, well, that's a bit of the secret sauce, but I can say that it's techniques such as like batching, caching, and we also built the entire engine from scratch. Like that's a big difference, I think. A lot of these other providers are built off existing solutions, but we built everything from scratch. And so that really helps us be very specialized for generative AI inference. And the company actually was born out of a research lab which worked on a specific batching technique. And I think that for sure is one of the techniques that gets us fast.
Got it. Yeah, awesome. So it's sort of primarily like some like algorithmic or like software improvements that's providing the superior inference speed.
Yes, yes, exactly. It's infrastructure as a software service, and in addition to like the higher level improvements like batching and caching, we also have very low level optimizations at the GPU kernel level.
Got it. Got it. Let's turn to the audience questions. So, Sumin, should we just look at these questions? Uh, have we answered Usman's question? How does tool calling differ in a multimodal system?
Yeah, I think I saw that question already. We can also talk more about it offline if you have more questions after that. I wait, let me put my yeah, if you find me on LinkedIn, we can definitely talk more about it after. I'll look at the latest question. So when we fine tune, do we have options to have agents that automates the optimize hyperparameters? Say it monitors loss curves for you. Oh, so are you asking if we can have AI agents that will automate the fine-tuning process of optimizing hyperparameters? Okay, I see. Um, in like, are you asking if it's on our current platform? On our current platform, the things like optimizing hyperparameters are not currently in our friendly suite, but we do have our own, like, it's not powered by AI agents per se, but we have our own like proprietary way of doing it. And we're also very good at quantization, which is something an additional task that you might want to do to get from like a open source model to something that you might want to use in production. Um, I'm not sure if it's in the roadmap, but I also think that's like it sounds like a good idea, and that could also be like a project that you could try working on. Like seems like a good idea.
Okay, maybe well, if anyone else wants to write in, I'll ask the question myself. So what do you see as sort of like the key benefits, or maybe sort of like some applications that seem very appealing but weren't possible without multimodal RAG and these multimodal models, as opposed to just like text only?
Ooh, I guess one really exciting area is in robotics, for example, where it's like has to really interact with its environment on a wider level than just like a chat-based text interface. So I know that in robotics, such as in like working in factories, for example, there's been a lot of exciting work being done with robots that are able to navigate like the entire factory on its own and make decisions on what next to do. And like, for example, if there's like something has fallen over and it can't take a certain path, like that's where multimodality would come into play, where it would need to actually analyze its environment and see what it's in front and then make the decision to take a different path.
Got it, got it. Yeah, I mean, definitely if we want agents that can do sort of like actual real world understanding, act in the real world, then yeah, this
Yeah.
seems like a very exciting direction. Um, okay, so we've got a question from Uzman. How does tool calling evolve in a multimodal system where models like um, O1, Mini, and Llama iteratively refine responses using the output of one model as the query for another until a desired confidence level or expected result is achieved? Um, what are your thoughts, Suman?
That's a really good question. I will say I'm not like a super expert on in this like iteratively refining responses, but I will say that I think when I've used it, I know it'll tell you like the reasoning, and then it'll tell you also when it's iteratively refining responses. At a certain point, it'll stop and be like, "Oh, I'm not getting anywhere." So for that, for example, there are many different ways that tool calling can be used there. Um, it's up to you, I think, or up to the developer to choose at what level of granularity you want the tools to be. You could have very specific tools like, oh, once this happens, output this very specific result. Or you can have like very like broader tools that give the agent more space to reason. And so I feel like for models that iteratively refine responses, um, Yeah, I can imagine that there's like a very wide array of possibilities for tools to be used to either like stop the iterative refining or ask for like specific like other call other models to see if the response is good enough. I know that's like also a very common pattern where one like expensive model is used and one cheap model is used, and there's also like a model used just to like benchmark like how good a response is. So yeah, in joining all of these together, I imagine there's like very many ways you could use tool calls. Yeah, involving a third model to gauge. And yeah, if you want to answer the how do we ensure efficient retrieval, error correction, and response optimization using Milvus?
Yeah. How do we ensure efficient retrieval, error correction, Milvus? Um, yeah. I think I would say maybe you could just elaborate on what you mean by uh, error correction, response optimization. So Milvus is just a vector database. So you've put chunks or items into it. The efficient retrieval that's sort of affected by like totally different factors related to how you've got it set up and how it's being used. Um, yeah, I think you have to clarify a bit what you mean by error correction and response optimization for me to answer that. But what if we move on to so we've got a question down the bottom. So does the LLM itself
Yeah, I can take that
yeah,
one.
sure.
So yeah, so the LLM itself is hosted on Friendly for inference. So you'll just receive an endpoint and like an API endpoint, and you can use that to get model responses. So it's not currently it's not the entire RAG application that's hosted on Friendly. You would for RAG you would use things like Milvus, and then but yeah, Friendly is just like the endpoint. Yeah.
and so uh, let's go over to Paul's question. So does your database have a way to suppress the hallucination problem, such as a hand constructed with 6 fingers? So I would say like that. So the hallucination problem, that's not really a function of the database as such. That's sort of related to the foundation model that you're using. LLM, large language vision model, etc. So but I mean, using a vector database that does reduce hallucinations overnight because you're providing extra context to your prompt, which is based on like facts that you've put into your database. And so that by itself reduces hallucination. And then, but I think this is like a big topic of how do you reduce the hallucination problem? We could have, a dozen companies and like a full full week of workshops. But yeah, so this definitely is one of the strengths of using a vector database in like a RAG system is that you can have your prompt is like grounded on information that is verified or approved in some way.
Yeah, definitely agree. RAG is a great way to reduce hallucinations, and there are also models with architectures such as like mixture of experts is a commonly getting popular architecture right now. And if you have like many different experts, you can I think that can sometimes help with hallucination as well if you are able to train it in such a way. I think it yeah, I think it depends. Like it's kind of when you really restrict your model to stop hallucinating, then you might lose out on some of like the creativity. But yeah, to answer your question again, like the database itself, as long as there is nothing that says there's a hand constructed with 6 fingers in the database, I I think the database itself would only help.
Yeah, and I would sort of question like, so is a hand with 6 fingers, is that like a hallucination, or is it just sort of like a lack of sort of like the sufficient or suitable training data for like a an image model? I think yeah, like maybe sort of like something like a hand with 6 fingers. I sort of like perhaps that's quite different from like a language model that's like telling you something that it's like a syntactically correct sentence, but it just contains made up information. All right. Well, looks like we're out of time there. So I wanted again to thank everyone for your time and your attention, and also Suman from Friendly AI. Before we go, do you have like a call to action you could share? Maybe it's like next steps if you're interested in exploring this technology, how to get in touch with you, etc.
Yes, I had it on the screen. Let me go back to it. Okay, here we are.
Or if you want to type a link in the chat, for example. Oh, yeah, here we
Oh,
go.
yes, that's a good idea too. Yeah, let me share my LinkedIn as well.
So yeah, I'm really excited. It's like a very well-engineered, increasingly popular system. So I'm looking forward to myself getting more into Friendly AI's offering, and hope that you can do the same.
Yeah, thank you so much. Thank you so much for having me. It's
Of
been a
course,
real
yeah,
pleasure.
it's a pleasure.